We've got a ball being thrown off essentially a 2-meter high cliff at an angle of 50 degrees to the horizon or to the horizontal with a speed or a velocity of 6 meters per second. So drew a rough little sketch down below so we can see what's going on. And we want to find the range of it, so that's always dx. So first of all, imagine the path. It's always some sort of parabola, just depends on where you start in the parabola. And that ball is going to end up somewhere down here at the end of the day. And we're trying to figure out how far from the cliff the ball ends up. What is dx? So once again, we're going to set this up in the x and in the y directions, and we're going to just go for it. So in the x direction, I have my usual 3 variables. dx, which is what we're looking for, my velocity in the x, and time. And in the y direction, we have, because we have accelerated motion in the y, we have our 5 variables: v initial, v final, dy, ay, and time. Now, when you've got a velocity that's at an angle, the first thing you always want to do is get the components of that velocity. So there's an x component here. I would go 6 cos 50 to get that x component. And when I do that, I get 3.86 meters per second. That's my x component. So that's right here. And I also have a y component that's up. And it is possible for the y component to be down if they threw this ball down at an angle. And that would be 6 sine 50. And that gives me 4.6. And it is up, so it's positive. I'm going to remember that the y is positive there. Now, we don't know v final. dy, because I'm starting higher than I finish, would be a vertical displacement of -2. The negative is important. And as usual, our acceleration is -9.8 meters per second squared. And we don't know time. Now, in order for us to solve for dx, we need time. So we want to focus on this column and solve for t. Now, the solution generally presented has you solving for t first off. So you find an equation without v final in it, and you go for it. Now, the one equation that doesn't have v final in it looks like this. And this is what makes this a type 3 question. It's not the setup. The setup's the same for every type of projectile. It's the mathematics. If you have a term in every spot here, you have to use the quadratic equation. So I do have a d term. It's -2. I have an initial velocity in the y, positive 4.6. Obviously, I have an acceleration. And because I've got a squared t and a t and something that's non-zero on the left, I have to use the quadratic formula. Whatever's in front of the t squared would be a. Whatever's in front of the t would be b. And when I move this over, that would become c. So when I subtract a d from both sides, that would be my c value. Now, there's lots of room for error when you do that, and it takes a little bit of time. So what I prefer to do is solve for v final first and pick an easier equation. So if I'm going to solve for v final in the y and I don't know time, the one formula that works well is this one. V final squared is v initial squared plus 2ad. Now, v initial is 4.6, and I've got to square that. I know my acceleration's -9.8. and I know my displacement is -2. Again, if you don't put the negative in there, it's not going to work. You've got to watch your signs with this. Now, you do all this on the right-hand side, and you take a square root, and you end up getting a velocity of 7.77 for your final. Now, always go back to your picture. We're finding the y final velocity here. The y values are positive all the way up to here for the velocity, and that's where the final y velocity is 0. And then it switches direction and gets bigger and bigger and bigger in the negative. So it's on its way down, obviously, when it hits the ground. So we're going to have to choose the -7.77 meters per second. Remember, when you take a square root, which is what you have to do here to get v final by itself, it's always positive or negative. We're going to pick the negative one because it's on its way down. So my final velocity in the y is -7.77 meters per second. So I can put that in here. And now I can pick a different equation to solve for time. I'm going to choose to pick this one. V final is V initial plus AT. So if I want to solve this for time, I simply go V final minus V initial, subtract VO from both sides, and then divide both sides by A, and I'll get T. So my value for time will be negative 7.77 minus V initial, which is 4.6, all over negative 9.8. And when you crank all that through, you end up getting a 1.26 seconds. Now, if by chance you forgot to take the negative on this question, and if I put in a positive 7.77 right here, you'd end up getting a negative time of negative 0.323. And of course, you can't have a negative time, so we would just automatically reject that. So now we have one step left. That's to find dx. So go back to our horizontal column, our x column. dx is vx times t. We know vx, 3.86 meters per second. We know the time. We're going to use 1.26. And when I multiply those things together, I get my answer, 4.87 meters.